Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to continue on our series of studies on statistical method 1. Today we are on what? Measure of position. Measure of position. We have our three main measures of position. We are going to work. I'm going to guide you guys to walk through them one by one. So the first on my list is what? Quartiles, right? So for quartiles, for instance, if we have been given raw data, right, for quartiles, we are going to divide the ordered data set into approximately 4 equal parts, right? With the raw data given to you, when you arrange them in order, you are going to divide them into what? 4 equal parts, right? And they are the Q1, Q2, and then Q3, where Q1 is equal to what? The first quartile. And the first quartile, that's Q1, is giving us 1 over 4 times n plus 1 position, right? 1 over 4 times n plus 1 what? Position. And then for the Q2, we have what we call the second quartile, right? And the second quartile is giving us 2 divided by 4 times n plus 1 position. And then for the third quartile, that's Q3, is what? The third quartile. And the third quartile is giving us 3 divided by 4 times n plus 1 what? Position, right? So this is the quartiles that we have. So after dividing the data set into 4 equal parts, they can ask you to find the first quartile, the second quartile, and the third quartile. And then the summary of all the formulas that we have written here is that if you have Q subscript k is equal to k divided by 4 times n plus 1 position, right? So if it is the first quarter, the k will be equal to what? 1. If it is the second quarter, k will be equal to 2. And if it is the third quarter, k is equal to what? 3. And most of the time, the second quarter is referred to as what? As the what? Median, right? As we have already treated that in our previous one video. So let's go through some examples for us to really understand what we have just discussed above, right? So for here, we are saying that compute the first quartile, second quartile, the third quartile, and what? Interquartile range of the data. So the first raw data that we have is what? 7, 18, 11, 6, 59, 17, 18, 56, 104, 20, 31, 8, 10, 15, and what? 19, right? So what we have to do, we have another second data set, but we will do the I1. When we are done, we work on what? The II, right? So the first data set that we have at the top there, right? The first thing that we have to do is to just arrange them in what? In order of magnitude. The least that we have here is what? 6, and the highest that we have there is what? 104. So we just arrange them in order, starting from 6, and then we are going to end at what? 104. So this is how one can arrange it in what? In order, right? So in order, we are going to have 6, 7, 8, 10, 11, 15, 17, 18, 18, 19, 20, 31, 54, 59, and then 104. So in order, I'm going to arrange it from what? Smallest to what? To highest, right? So for the first quarter, you saw it in the formula that Q1 is equal to 1 over 4 times n plus 1 position, right? So here we have to, after arranging it in order, we have to know our total number of observation. That will be what? Represented by what? Our n, right? So we have to count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That is what? 15 observations. So here our n is equal to what? 15. So all that we are going to do is to just for the first quarter, we are going to replace 15 to wherever we see our n, right? So here we are going to replace 15 there. So here we are going to get 1 over 4 times 15 plus 1 position, which will be equal to 1 over 4 times 16 what? Position. And then 4 can cancel 16. You are going to have what? 4 position, right? Because this 4 will cancel 16. You are going to get 4 times raised to the power the position. That's the th, the position. So that means that we are going back to what? The raw the raw data that we have been arranged in order and count until we get what? The 4th position. So we're starting from the 6. 6 is the first position, 7 is the second position, 8 is the third position, and then 10 is what? the fourth position. So here our first quartile will be what? 10. As simple as that, right? So for the second quartile, we are going to have 2 divided by 4 times n plus 1 position. We already know our n to be what? 15. So here will be 2 divided by 4 times 15 plus 1, which will be 2 over 4 times 16. And then once you do it, well, we are going to get 8th position. You mean that we are going to count until we get to what? The 8th position, right? So here will be 6, 7, 8, 10, 11, 15, 17, and what? 18. So the 18 is what? Our 8th position. So here our Q2 is what? 18. Right? As simple as that, right? So for the third quartile, this is how it's going to be. It's going to be 3 divided by 4 times n plus 1 what? Position. We just replace our n by what? 15, and then you are going to get 3 divided by 4 times 16 position. And I'm going to get what? 12 what? Positions. You are going straight to the distance and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 31 is what? The 12th position. So here our third quartile will be what? 31. And then we have been asked to calculate for what? The interquartile range. The interquartile range is equal to what? The third quartile minus what? The first quartile. So what we are going to have is what? 31 minus 10, which is surely going to give us what? 21. As simple as that, right? So let's go to what? Our second question. For our second question, you have to arrange it in order. So here when you come up, arrange it in order. We have 4, 15, 19, 20, 25, 33, and what? 37. Right? So I have been able to arrange this one in what? In order. And then we have been asked to calculate for what? The first quartile. So here we have to know the our n. So let's count the observation. 1, 2, 3, 4, 5, 6, 7. So our n is equal to what? 7. So here our first quartile will be what? 1 divided by 4 times 7 plus 1 position. Right? Yes, because we know that our n is what? 7. So we are going to replace our n by 7. And you know that our first quartile Q1 is equal to 1 over 4 times n plus 1 position. Right? So we are just replacing the n by 7. We are getting 1 over 4 times what? 8 position. And then here we are going to get Q1 to what? The second what? Position. So for the second position, because you are going to get 1 over 4 times 8 position. When 4 goes to 8, you are getting 2 position. So you are just going here to count 1, 2. So the 15 is what? The second position. So our Q1 is what? 15. So let's go to Q2. So for Q2, you are going to have 2 divided by 4 times n plus 1 position. Right? So here we are going to have 2 divided by 4 times 8 position. Right? So this 4 will go to 8. How many times? 2. 2 times 2 give us what? 4. So Q2 will be at what? The 4th position. Right? So let's count. 1, 2, 3, 4. That is what? 20. Right? So our Q2 is what? 20. Let's go to Q3. So for Q3, we are going to get 3 divided by 4 times 7 plus 1 position. Of which you are going to get 3 divided by 4 times what? 8 position. Right? This one will go here 2 times time. That we are going to get 6. So 6th position. Let's count. 1, 2, 3, 4, 5, 6. So the 33 is what? Our 6th position. So our Q3 is what? 33. And you have been asked to calculate for the interquartile range, right? The interquartile range 2 is what? Q3 minus Q1. So Q3 minus Q, right? That's 33 minus 15. Of which you are getting what? 18. Right? You are getting what? 18. So that is what? The solution to the example given above. So you see, it's very, very simple, right? Let's continue with example solving. You see, one thing you have to note here is that sometimes our n will be what? Even. Sometimes our n will be odd. When our n is odd, the solution to the quartiles is very, very simple. But what about when our n is what? Even. When our n is even, sometimes you'll be getting decimals when you do calculate for it, right? So most of the times, what you usually do is that when n is even, right? When our n is even, right? You have to divide the data set into 2 because you can divide it evenly, right? So for instance, the data that you have here, all that you have to do is to arrange the data from smallest to highest, right? So when you arrange the data from smallest to highest, from this one you see our n is what? 6, right? Our n is equal to 6. So if you follow this formula, we are going to land into what? Decimals, of which it can create problems for us, right? We have a way when we have decimals we can solve it, but I'm going to show you the easy approach that you will not go through the long formula to get your first quarter and second quarter. So what we will do is first arrange it in order, right? This one 3, 6, 15, 12, 8 and 7, they are not in order. So we will come here and then just arrange the whole of this thing in what? In order. When you arrange it in order, what you have to do is to just divide it into 2, right? So here you are going to divide it into 2. You are having 3, 6, and what, 7, right? Comma 8, 12, and what, 15, right? So here you have grouped it into 2. So if you are asked to find the first quarter, so for the first quarter you come to the first grouping. This one is the first grouping, right? First grouping, and this one will be what, second grouping. You come to the first quarter and choose what, the middle, right, number. So when you come to the first quarter, we choose the middle number, and the middle number is what, 6. So here our first quarter is what, 6. If you are asked to find the third quarter, you come to the second grouping, right? You come to what, the second grouping and choose the middle. So when you come to the second grouping, the middle is what, right? The third quarter, the middle is what, 12. So our third quarter is what, 12, right? So let's come to the second quarter. That's Q2. For Q2 is equal to what? Median. But yeah, like you finding the midpoint, right? So for the Q22, you come and then you choose the 2 middle number, right? Like this one. This is the 2 middle number, and then find the midpoint of that, right? Sorry, this one is not even arranged in order. You come to what is arranged in order, and then choose the middle number, right? So when you choose, you are going to have 7 coming. You are going to have 7. You are going to have 7. You are going to choose 7 and 8. So here will be 7 plus 8 divided by 2. You are going to have 15 divided by 2, and our final answer will be what? 7.5. Right? So here our second quarter is what? 7.5. So this is how we will work. We will solve our quarters when our n is what? Even. When our n is odd, we are going to use the formula that I show you first. But if our n is even, we just divide it into 2. The middle ones will be what? The first quarter, and then the third quarter, and then you choose the midpoint to be your second quarter, and then the work is done. So let's go to what? The percentile, right? So for percentile, when a raw data set is given to you, first divide an ordered data set into approximately 100 equal parts, and then they are P1, P2, P3 out to what? P99. So simply we are going to have the formula to be this: P subscript K is equal to what? K divided by what? 100 times n plus 1 position, right? So this is an example. I've been given this example. We said given 3, 6, 15, 12, 8, 9, and 7, right? We should find P subscript 25, P subscript 50, P subscript what? 75, right? And then we know that the subscript here is K. So when we come here in the question, K is what? 25, K is 50, and K is 75. We are just going to arrange this here in order, right? We are just going to arrange it in order, right? So first, all that you have to do is to just arrange them in what? In order. When you arrange it in order, you write your formula here. And the first question is asking us to calculate for what? P subscript what? 25. So P subscript 25 here is equal to, we see our K here is what? 25. So you are going to just replace, everywhere we see K, you are going to replace it by what? 25. So you are going to have 25 divided by what? 100 times n plus 1. But we know that we have to count our number of observation to replace what? Our n. So here are going to have 1, 2, 3, 4, 5, 6, 7. So our n here is what? 7, right? So it will be 25 divided by 100 times 7 plus 1 position, right? So here will give us 1 over 4 times what? 8. Because 7 plus 1 is what? 8 position, right? So this one will go here how many times? 2. We are going to have second position. So when we come to the arranged data, you choose what? Your second position. And our second position here is what? 6, right? Let's go to what? The next one. We have about P subscript what? 50. So for P subscript 50, we are just going to replace where the K is by 50. So you are going to have 50 divided by what? 100 times 7 plus 1 position, right? So here the 50 will go to 50 divided by 100 will be given as what? 1 divided by 2 times 8 position. We are going to get what? The 4th position, right? So we come to the list here and then just choose the 4th position, and the 4th position here is what? 8, right? So we get our 8. And let's come to what? P subscript 75. So P subscript 75 will also be represented by 75 divided by 100 times 7 plus 1 position, right? So 3 divided by 4. When you divide 75 by 100, you are going to get 3 divided by 4 times 8 position. This times that is going to give us 2. 2 times 3 is going to give us what? 6th position. And for our 6th position, we just come to our ordered pair here. 1, 2, 3, 4, 5, 6, right? And then that 10, so we are going to get what? 12. So this is how we will calculate for what? Our percentiles, right? So let's go to the last quartiles, right? For this one, for the raw data, I'm just going to divide them in an ordered data set into approximately 10 equal parts, and they are D1, D subscript D1, D subscript 2, D subscript 3, up to what? D subscript what? 9. And this is how it is represented by D subscript K is equal to K divided by 10 times n plus 1 position, right? N plus 1 position. So here, given this data set, 16, 11, 13, 19, 5, 7, 8, 4, and 2. What you have to do is just arrange them in order. So you have been asked, right? You have been asked to calculate for what? You have to find our D2, D4, right? D4 and what? D6. D2, D4 and what? D6, right? So first you have to arrange the whole of this raw data in order. We have 2, 4, 5, 7, 8, 11, 13, 16, and what? 19. Then we know that D subscript K is equal to K divided by 10 times n plus 1 position, right? So here, anywhere you see, for what we will be solving for D subscript 2, right? So anywhere you see K, you replace it by what? 2. So D subscript 2 is equal to 2 divided by 100 times what? 9 plus 1 position, because we know that our n is what? 9. When you count this, 1, 2, 3, 4, 5, 6, 7, 8, 9. Our n is what? 9, right? So here we having 2 divided by 10 times what? 9 plus 1 position, of which we are going to get what? 9 plus 1 is 10. 10 divided by 10 is what? 1. So you are going to get what? 2nd position, right? So we come here and then we select what? 4 to be what? Our D subscript what? 2. That's D2, right? For D4, you are going to have 4 subscript what? 100 times 4 subscript what? 10 times 10, 9 plus 1 position, right? Of which you are going to get 4 divided by 100, 10 times what? 10 position. This one will cancel that. We are going to get what? 4th position. When we come here, 7 is what? Our 4th what? Position. And the last one is what? D6. So you are going to have 6 divided by 100 times 9 plus 1 position. So here you are going to have 6 divided by 100 times 6 divided by 10 times what? 10. We are going to get 6th position. So for the 6th position, you will count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? 6. So this thing is what? 11. And we are having our D6 to be what? 11. So this is Statistics and Mathematics YouTube channel. If you haven't subscribed, kindly subscribe, like, and share, so that this video will go viral for people to also watch. Please don't forget to leave your comment at the comment section. Bye. Have a great day.